Thank you. If everybody could take a seat, we want to get started. So good morning, ladies and gentlemen. I'm very excited to welcome you to our 2023 NRMCA General Session. Before we hear from our keynote speaker, we would like to acknowledge our NRMCA super sponsors. You'll see this as a recurring theme to be able to say thank you to those companies that have offered their sponsorship dollars for these events. Alphabetically, the super sponsors are CRESO, GCP Applied Technologies, Euclid Chemical, who was having a big party up here with Mike Krause a little bit ago. I'm surprised the keg didn't roll out. Master Builder Solutions, and SICA. We'd also like to acknowledge our NRMCA 2023 annual convention premier sponsors. Alphabetically again, the premier sponsors are Command Alcon and Heidelberg Materials. Finally, we have a special sponsor for this session that helped make it possible, and that company is Wholesome. Let's watch a short video. I would now like to introduce our general session speaker, Dr. Tyler Ley. Let me tell you a little bit about Tyler. He has more than 20 years of experience in the fields of structural and concrete materials engineering. During this time, he has worked as an engineer with a design consultant, construction contractor, government agency, and for the last, he told me, 15 years, as a professor at Oklahoma State University. Over this period, Tyler has been recognized with a variety of awards from academia, as well as industry. I'd go into all of them, but it would take too long, so I'm going to cut that short. Through his work, Dr. Ley has received funding from industry, state, private, and federal sources, and several of his projects have created innovative products that have led to patent applications and changes in national codes and standards. He is very active in the American Concrete Institute as a voting member of the Concrete Durability, Material Science, Concrete Proportioning, and Sustainable Technical Committees. Anybody else can say that in this room? Just raise a hand. That's pretty impressive. In addition, he serves on the executive committee of the National Concrete Consortium, a group made up of DOT engineers from 35 different states. Tyler has a passion for creating innovative learning content, and his websites are visited by over 50,000 people each year, and his education content on YouTube has been watched over 6 million times. Tyler is going to share with us today his insights into the current and emerging technologies that aim to improve the sustainability of concrete mixtures and tools to help concrete producers evaluate those opportunities. I don't think you'll ever see a person in the concrete industry with more energy than Dr. Tyler Ley.
Mike, thank you so much. Appreciate it. Wow, you guys know how to party here, don't you? I know it's Vegas and all, but you bring it. Well, I want to say thank you so much for having me. Thank you for what you do every day, and Thank you for getting together and make our industry better. We need people like you, and you are the best of the best if you're here. You're pushing and trying to make us improve. But I'm going to talk about providing sustainability through innovation. And I got to first start out with acknowledgments. So big thanks to Greg and Jessica. I wouldn't be here without them. Brian Killingsworth, man, appreciate you, brother. Road warrior, send him all over the place. He preaches about sustainability. And there's a few slides that I've borrowed from his, and I'll actually mention those today. Big thanks to Dan and Melissa from Oklahoma. Keep me out of trouble and give me some great advice on what to cover, what not to cover, how to reach you guys, because that's what I really want to do today. I want to help you. I want to reach you. I want to serve you with the time that I have together. And so a big thanks to NRMCA and Oklahoma DOT for funding some of the stuff that I'm going to talk about. But why do I do what I do? If you don't know who I am, I believe concrete is the greatest material on the planet. And I'll battle anyone that says differently. Thank you. And every day, I want to make concrete faster, more durable, more sustainable, easier to construct with. I just want to make it better. That's my mantra, to get up, put my feet down on the floor, and let's say, how can we make concrete great today? And what I do is I help build people, and I help build tools to help make our industry the best that it possibly can be. And if you haven't seen my YouTube channel out there, you might want to check it out. I mean, if you want to train people, if you want to share ideas, if you want to just say, well, how do I explain this in about 6 minutes that might make you laugh a little bit? I've probably got a YouTube video about it. I've got about 300 of them. I'm up to about 9.5 million views now, which is awesome. And if you're not a subscriber, please, please, please subscribe, because if I get to 100,000, I get a trophy. I get a YouTube trophy, a play button, and I'd love to get a play button. And but really, simply put, I love concrete, baby. I mean, concrete is just part of me. It's in my soul. And the last few years have not been great for our industry. It's just not been. We've had press that looks stuff like this, where it says some really bad things about concrete. But if you go to read those stories, you realize that those people don't really know us. And they don't really know our industry. They don't really know what we do and what we're about and where we're headed and how hard we're working to be better every day. So I just think these are kind of goofy, okay, every time I read them. But it's good. It's important. You probably guys know this. Concrete is the second most used commodity on the planet. There's 6.5 billion cubic meters of concrete placed every year. That's a sidewalk around the earth 1,400 times every single year. When you do things like that, when you give that much great things to humanity, whether it's homes, whether it's clean water, whether it's transportation, whether it's whatever, there's going to be some cost with that. People need to understand that. There's always going to be some cost with that. And that's why people say 5% of man-made CO2 emissions are actually from production of concrete. And I'm proud to say in the United States, that number is around 1%, okay? Around 1%, which is pretty cool. But don't ever let anyone say or tell you that concrete's a dirty or dangerous material, because it's not. Because there's so much more good, in my opinion, than any bad that it produces, but we can be better. We can be better, and you guys have recognized that. You guys have already seen that. This is one of Brian's slides. You've got your roadmap. PCA is joined up with you guys. You guys are making progress. I love the 5 C's. I love where you're headed. I love what you're doing. The state government has set targets for us. State government, the federal government has said we want to reduce our 2005 CO2 targets by 50% by the year 2030, and we want to reduce it by 100% by the year 2050. Wow, this is pretty cool. So have you ever wondered, how are we doing? You ever wondered that? How are we doing? How are things going? Are they good? Are they bad? Are we, where are we at on this? Well, I looked up some data, some EPA data. So that's federal EPA data. And I'm showing on the y-axis there is the percent reduction in CO2 based on 2005. That means, where did we start out in 2005? That's 100%. It's 100%. And then where are we at today? You can see a few data points on there. And one data point there is that's a target, 50% reduction by the year 2030. There's another data point on there, 2050. We're getting down to 0. That's the goal. That's where we're headed. And one thing that's awesome is we've already reduced 25% so far, and we haven't really put all of our efforts behind it. We really haven't. We've just been business as usual, improving over time, and then with Portland limestone cement, a massive effort massive, massive, amazing effort that people pushed forward, made things better. We've started to make some better, but we're 25% on the way there, and we really haven't put our efforts behind it. Okay, so I think we should feel good about that. I think that's a good thing. Don't you think? Is that a good thing? I think that's a good thing. If you're not sure what I'm talking about, I'm basically saying if you're going to go get some free coffee, you know those free coffee cards where you got how many cups of coffee do I have to buy to get a free one? Baby, we are already 2 coffee cups down. We're almost all the way there. We got some more to go, okay? But we're moving, and I mean that to be in a positive way, because if we're positive, it's a lot more energy. It's a lot easier to move forward and do new things than it is if, I'm not so sure, how are we going to do this? So we can move ahead. But how are we going to get the rest of the 8 cups there? How are we going to figure that out? And that's really simply innovation. It's going to be innovation, and it's going to be everyone in this room, and I mean everyone in this room, pushing and pulling and learning and growing and doing something different that you haven't done before. And that might make you feel a little nervous inside. That may make you feel like I'm not so sure. What am I going to do? What are they going to ask me to do? Oh, don't worry. We'll tell you all about it. This group's going to do a really good job letting you know what they need and what they're all about. But I'll tell you where it really starts down with is our owners focused on sustainability. Because as an industry, as a ready-mix industry, we can only do so much ourselves because we have to serve these people. We have to come in at economical prices. So the owners have to be the ones that are going to have to step up and say, I want to pay to make this happen. I want to put my money, my efforts, my abilities forward to try to make this happen. He said, well, are owners really doing this? Are they focused on this? Are they dedicated to make this happen? Well, another one of Brian's slides. This is where Brian has collected a whole list of people here, and there's more. There's more, and I'm not knocking the slide. It couldn't even fit on the slide. There's more and more people generating these things, generating these laws and things like that. These are cities, these are local areas, states that are saying that they want to put their money behind it. They want to make efforts to make this happen. Another one of Brian's slides where we talk about HR 3684. I'm sure you guys talked a lot about this. I think you should be talking a lot about this. This is a massive, massive opportunity for you. Okay, in summary, what this means, if you haven't seen, I see some people taking pictures, which is good. I'll pause just a little bit longer. It's always good to get some pictures taken. But if you total the numbers up there, that's 15 with 10 zeros. That's a lot of zeros. I like zeros, don't you? As long as they're at behind numbers, not in front of numbers, right? You know what I'm talking about, right? 15 with 10 zeros. $150 billion, what that's supposed to be. And 25% of it is focused specifically for sustainability to help move that forward. So there's money. There's money. So okay, that's the federal government. That's that stuff. Now, I like concrete, like a lot, like a ton. And I don't just teach. I also help different clients, different industries. And these are some of the clients that I've worked with in 2021 and 2022. You could call it consulting. You could call it helping. I call it learning. Because I can learn a lot from books, but when I talk to the people that do it every day, that's when you really learn. That's when you really learn how you can help these people. These are all clients that I worked with in 2021 and 2022. 65% of them had a sustainability focus. It's not just Meta. It's not just Amazon. 65% of the people I worked with wanted to be better in sustainability, were willing to spend money in sustainability to be better. This is not just the government side. It's private. It's very, very interesting. And I was thinking about how could I help you, or how could I best serve you? And I thought if I told the story about how I work with some of these companies, that might be the best thing that I could ever do. Maybe I've worked with you, maybe I haven't, but maybe if you know the path, maybe that makes it easier. Maybe you could bring the path to you. So let's talk about that. How do I help these organizations? If I could summarize it in 4 bullet points, it's this, and this is the outline for the rest of my talk. I'm going to be talking about these 4 bullet points in detail. Number 1, you got to set everyone up for success. Number 2, you got to use EPDs to benchmark where we're at. Number 3, you got to set quality control expectations. That's really important. What do we expect to get out of this concrete? How do we know it? How do we don't? And then number 4, design mixtures to reduce and embody carbon. And I'll talk about that last. And that's truly the last step. The mix design process, the adjusting what we do every day, is the last step. You got to get everyone on board first to figure out where's the train going, how much they're going to pay to take the train, before we can figure out how we're going to make those changes. I hope that makes sense what I'm saying there. Okay? So let's jump in here. Set everyone up for success. You're like, oh my gosh, Tyler, it sounds like herding cats, right? Like herding cats, that sounds like impossible. No, it's not herding cats at all. Because people are aligned. Because people want the same thing. Everyone's got to be set up for success. Owner wants to be more sustainable. That's usually reducing CO2. And there's lots of ways to reduce CO2, and you should hear Michelle Wilson gives a great talk about this. Brian gives a great talk about this. So it's not just about the mix. It's about construction. It's about performance. It's about how long it's going to last. It's about taking it out of commission. It is, and that's all true. But everyone right now, for right or wrong, is focused on what is my first CO2 costs? What is the mix? That's what they're focusing on, probably because it's the easiest to actually quantify. And we will get to the other stages, but that's what people are focusing on right now. So the owners, they get this, they understand this, they have people that are trained in this, and they say, I want to be more sustainable because my stockholders or my owners or whomever are extremely interested in this. I want to make it happen. And that's where it's got to start. And they have to have a contractor. Usually a concrete contractor, general contractor, and they've got to hire me, okay? They want to help the owner give them the best product they possibly can. I love it. They're trying to serve them, trying to help them, trying to raise them up and make them better, trying to give them value. And I work with that contractor and the ready mix producer to make this happen. And so what questions do we ask? These questions are crazy valuable. What coarse aggregate sizes do you have? And what gradations? Sounds pretty simple, right? Got to ask the question. What's your sand gradation? What SCMs do you have available, and which ones can you get? Not that complicated so far, but it's important. We have to see what's on the table. Do you have experience with high-volume SCM mixtures? Because sometimes that's what it takes. Sometimes that's what it takes. If you don't have experience with high-volume SCMs, that's supplementary cementitious materials, okay, then that might be something you want to play around with, but that's what people ask for. And then can you share your mixture for this, maybe slab on grade, maybe a wall, whatever, and have you generated an EPD? That's a really big deal. That's a really big question. Do you know about EPDs? Have you generated EPDs? And then we say, how much does this cost? That's really important. You should not do work for free. If someone asks you to put an extra patty on top of the hamburger, they shouldn't expect to get it for free. That's a really important concept. So we use this information that everyone provides, and I usually propose 2 or 3 mixtures, okay? I look at all this information, I propose 2 or 3 mixtures, and then there's a conversation between the ready mix producer. We tweak things, we change things. Oh, okay, you want to do this? You want to use that admixture? Whatever it is they want. And then we quantify the CO2 savings and the cost for each mixture, and we let the owner decide. What do they want to pay for? And on some jobs, they'll pay. On other jobs, they won't, but it's a decision. And you're like, this isn't complicated. It's not complicated at all, but what's the secret? It's communication. It's collaboration. It's being honest about what people expect and what the risks are. Being honest. So why are you worried about that? What's your concern with that? How can we help you with that? What can we do about that? It's paying for trial placements to get people feeling more comfortable. Paying for trial placements, trial slabs, trial pumping, trial whatever, making it a line item that's paid for, and then learning and getting better every time. Learning and getting better. And then innovation is the last one. And this isn't the secret just for this. Boy, if you put this list down, this is a secret for a great job, isn't it? That's what we're trying to do here. Build a team, make everyone on the same page, see what's going on. Okay. So then the next thing is we want to use EPDs to benchmark where we're at. What are we doing? Where we're at? What kind of impact? And if you don't know what an EPD is, it's an environmental product declaration. We got any EPDs? Does anyone know about EPDs in here? Got a few EPDs, people? Okay. So we'll talk just a little bit about those, okay? Just a bit. Okay, EPDs, they're very simple. They're nutrition labels for concrete. You got a nutrition label, it tells you all kinds of stuff about it, and then we've got an EPD. Typically, there's lots of stuff on nutrition labels you can focus on. We often focus on calories. And you can say, oh, that's short-sighted. That's true. That's true. That's true. But because, maybe it's fat that's important to you. Maybe it's protein that's important to you. Maybe it's something else that's important to you. But people often focus on calories. And you can say the same thing for an EPD. There's a lot of things an EPD lists. But the thing that people often focus on is this global warming potential, this CO2 equivalent, all right? That's what they focus on, right? And there'll be more coming up. There you go. This is an easy way, just like a nutrition label at the grocery store. This is a way to compare and talk and whatever. So why are people doing this? Because it's this common language. It's a language that we can all use to understand one another, to see what it is, to actually compare what it is you're offering, what people are asking for. And it's like ordering a steak. Now, I'm from Oklahoma. We got good steak in Oklahoma. I've had some steak here too. It's pretty good, but we got some good steak in Oklahoma. And when I go to order a steak, I know immediately, if I tell someone medium or medium rare, I know it's just universally known around the world. Now, I don't know how long it took everyone to get there, okay? But it's universally around the world. When I say medium, they know what I'm talking about, right? That's what the EPDs are about. That's what they're talking about. When I have a number, I can compare them. This is a standard language just like we do to order a steak. So this allows different CO2 reducing technologies to be compared in an unbiased way. It's really important. There's going to be all kinds of innovations, all kinds of mixes, all kinds of technology, and this is a way to compare them in an unbiased way. So for example, if I've got some mixes here, and I have on the y-axis the percent reduction in CO2, okay, percent reduction. So we have a baseline mix for 2016. And then we had one mix for 2021. Now, why are they different? Because we've gotten better at producing cement. Every year, we're getting more efficient and better. So that lowered it a little. This client's benchmark was 2016 for some reason. And we showed, oh, if I go to a 20% fly ash mix, 77% reduction. That's pretty cool. That's pretty cool. Okay, if I go to 30%, that's a 68% reduction. And they said, well, okay, well, what if I brought in slag? What if I brought in slag? How's that going to do? Now, this is a special case. This is going to seem strange to some people, but if I bring in slag, the numbers were higher for this project. What? Higher? What's going on? Well, it happened. They had to bring the slag in from a long way away. Sorry, Lori, but yeah, they did. They had to bring the slag in from a long way away. And so when you use an EPD, it's not just about pounds of cement. You really, truly understand what went into that material, to getting it there, to doing that thing, right? But I do want to go on record of saying that slag, if you have slag that's locally available, if you have it in your market, that is a great choice because you can use 40% and you don't see a lot of impact. You can use 50%, you don't see a lot of impact, okay? So it's a great choice, all right? But you guys are leaders in EPDs, okay? 77,000 valid EPDs out there from US and Canada. I mean, seriously, you guys need to give a round of applause. Seriously. This is huge, what you've been able to do. Okay, this is a really big deal. You have been leading the charge in making this happen. It's been awesome. Okay, you've been establishing PCR and ISO standards. You have industry averages. You have education and communication tools. Oftentimes, and we want to help people better understand what's going on, we use NRMCA and PCA tools to help them and see what's going on. So you are making a massive difference, and as we move ahead, your stuff, your groundwork, your foundation is going to be really, 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 really powerful. So that's the EPDs. So now we want to set quality control expectations. That's really important, because sometimes we may be doing something different. For example, if I'm using a mixture with a high amount of slag or a high amount of fly ash, what's the early age strength gain going to look like? What's the setting time going to look like? How is it going to finish differently? These expectations, these conversations have to happen. We have to talk about them. We have to get in front of these things. And one question we always ask is, how do we make sure concrete is done right? I mean, seriously, how do we make sure that concrete's done right? And in our industry right now, we use 3 simple tests. We use the slump test, we use the strength test, and we use air test. And that's great. They're useful, they're cool, they've served us for a long time. They're not bad. They're not. But what should we be testing? Well, I would argue that we should be testing properties that are more closely tied to performance, okay? And that you guys have pioneered this. You guys, more than a decade ago, started talking about this. Colin Lobo, Karthik Obla, You guys talked about the P2P, prescription to performance efforts, okay, which is really cool. But really, all of this can be summarized at the bottom one. We get better answers by measuring better things. Now, is a slump test everything? I think you know it's not. Is a strength test everything? No, I think you know it's not. I think there's more to the story that's going on. And some of these projects going ahead, we have to measure what matters. We have to measure what's important and measure it well. And if we do that, that'll make our lives better. So if we go back to these three things, what I'm going to talk about and focus on are strength cylinders, okay? Strength cylinders are cool. There's good things about them. But I want to ask, and I hope you'll be honest with me. I know nobody likes to talk about this, but have you ever been penalized for low strength? Anyone? Anyone ever been penalized for low strength ever? The left-hand side of the room is a little more brave than the right-hand side of the room, okay? I'm just being honest, okay? Nobody wants to admit it, right, that they've been penalized a few times. Our industry is obsessed with strength. It's not always benefiting us. Okay, we're paid on it. It's easy to measure, and humans inherently think strong things are good. You know, which one do you want? I want the strong one. Do we always want the strong one? Is the strong one always the best? I'm not sure. Sometimes it is and sometimes it's not. It depends on the action. What am I talking about? If I have a team and I'm trying to, trying to figure a really cool challenge out, maybe I don't need the strongest one. Maybe I need the smartest one. Maybe I need the one that can, communicate the best. Maybe I need the one that can make everyone feel confident and move ahead together. It just depends, okay? But this bottom underlined sentence is really important. And I know you've seen this. Low strengths on job sites are often caused by poor sample handling. Often caused by poor sample handling. And one reason we add a lot of extra cement to our mixtures is to handle this, to head this off. We put an extra safety factor in our concretes because we don't want this to happen. That's what everyone pays us on. That ain't happening. They're not taking my money away. I'm putting more cement in. What if we could handle that? What if we could address that? What if we could make people feel more confident? You're like, Tyler, that sounds super hard. And I get it. For example, here is a curing box. A curing box is like a fancy ice chest that's to keep my cylinders at a standard controlled temperature range so that they gain strength as they should. And there was a job, I'm so proud of these specifiers, so proud of them. They'd heard me talk about this and they said, we're going to specify a curing box. They write in there, testers shall use a curing box and whatever and all that stuff like that. Man, they feel so good about themselves. And this is what happened on the job site. I'm being dead serious. That's a box. Cylinders are curing inside. But I'm not sure that's what they had in mind. Okay? When concrete cylinders don't reach the specified strength, the ready-mix producer is blamed for the mix not being right. That's what happens, in my experience. And we need a way to address this. We really, really do. But what if we could measure the water-to-cement ratio in fresh concrete? What if you could show that the concrete meets the specification as it leaves the plant? What a way to protect yourself. We would measure what matters, because really water-cement ratio is the key thing. I'll talk about that in just a second. I'd place less of an emphasis on strength and slump specifications, which I think is huge. What am I talking about? Water-cement ratio, it's the mass of the water divided by the mass of the total cementitious materials, the fly ash, the slag, the cement, all that stuff like that. It happens to be the most important parameter for determining the strength, the durability, and the consistency of your concrete. Extremely powerful, powerful, powerful thing here. And if you still don't understand what I'm saying, I've got two pictures here, one on the left and one on the right. And those little gray dots are cement grains. And the one on the left's got more cement grains in the box than the one on the right. Does that make sense to everybody? So it's got a lower water-to-cement ratio. Okay? Now, what would be amazing, what would be so amazing, is if we could just look at the concrete and know exactly how much water cement ratio there was. Like, wouldn't that be cool? It'd be like Kool-Aid. Kool-Aid, you guys made Kool-Aid, right, before? Right? When you're making the Kool-Aid, if someone gets the Kool-Aid ratio off, the kid knows instantly. I did. Did you know? Mom, you added too much water. Right? Because the flavor crystals, you know, they're too far apart when you add too much water. That's what we're doing. We're diluting when we add too much water to our concrete, right? And why that matters is that when things start to grow, when cement starts to hydrate and grow, I can't see them very well on my screen, but you can see them great on your screens. I got more bonds on the left and less bonds on the right. Okay? More bonds. More bonds are good. So that means if I go to load this, there'll be more ways for the load to transfer on the left. That's why it's stronger than on the right. Let's say there's outside chemicals that want to penetrate inside the concrete. Outside chemicals want to penetrate. There it is. On the left, does a really good job of keeping the outside chemicals out. On the right, it's much easier for them to get inside. This is succinctly why water cement ratio is so important. And when people started to try to measure slump, and when they started to try to measure strength, they were trying to get some kind of indication to what's going on with the water cement ratio. But what would be cool if we could just measure it directly? Well, why would the water ever be off? Well, sometimes our moisture contents are off. Sometimes our batch tolerances are off. Sometimes the wrong amount of water is added, and then there's something called renegade water. Now, I got to promote right off the bat, like, what is renegade water? What's that all about? Well, here is Oklahoma's most famous renegade, Pistol Pete. He is my mascot. That's right. Go Pokes, right? He's got guns, so he's a renegade. Watch out. But what is renegade water? Well, it's water that's not on the batch ticket for whatever reason. Could be the contractor added it, could be it was in the truck, could be whatever, for whatever reason. And how can we protect ourselves from this? Someone adding water to the concrete that we have nothing to do with impacting our concrete. Well, how we handle it now is we add more cement. That's how we handle it right now. Okay? All right? And how much extra water matters? Well, if I have an 8 cubic yard mix, 6 sacks, if I add 5 gallons, that increases the water cement ratio about 0.01. That's 150 PSI. That's a year's of service. And then people have said, well, okay, well, there is this test called the microwave oven test. We could talk about it. You collect a certain amount of concrete. You weigh it. You remove the water with heat. You weigh it again. Sounds simple. It's not simple. Okay? It takes 40 minutes. It's super labor intensive. The results are variable. Here's how the test works. On the left-hand side is the mass. On the right-hand side, on the bottom, is the time. And what you're doing is you cook it. You have to open it up. You have to break it up. Hopefully you don't lose anything. Put it back in and cook it for 5 more minutes and do it again, do it again, and do it again. And in the test, the way the test works is you only use 1,500 grams. 1,500 grams. That's a third of a 4x8 cylinder in the test. And that's one of the big faults of the test, the big challenges with the test. And that's why it's not used. It shouldn't be used. It's not accurate. It's not useful for us, okay? But this industry would benefit from a test that could measure the water cement ratio in fresh concrete. And there are definitely challenges with the microwave oven. But I'm going to talk about a test called the Phoenix that I think is a helpful test, okay, that you can learn more about, all right? And this test is pretty simple. This test, you have to have the batch ticket, and you need to know some information about the aggregate. You need to know about the specific gravity of the aggregate. You need to know about the absorption. Those are things we need to make mixed designs anyway. Then you're going to make and weigh a small cylinder, 6-inch diameter, 4-inch deep. You're going to dump the cylinder into a pan and weigh it. Then you're going to start the test, come back 15 minutes and weigh it again. Now, one thing I left out is that when you go to actually start the test, you weigh the cylinder empty, and then you weigh it full of concrete, and then you weigh it after you dump it out. Why do you do that? You've got to make sure they dumped all the concrete out. You weigh the pan empty, you weigh it full, and you put it in the oven, you cook it, and you weigh it again until you measure and you've released the water out of that mix, okay? So in pictures, you need a batch ticket and information. You need a cylinder and a scale. You need a pan. Dump it out, smooth it out in the pan, okay? And then you put it in this awesome kiln. Very specialized kiln. It's got heating elements on the top and the bottom, and it just really heats that water out of the concrete. Then you take it out and you measure it again, okay? And you say that's the dried concrete. And what happens in this test is over time, you remove water. It takes about 15 minutes, and you take all the water out. All the water from the paste, all the water from the aggregates, every bit of it. All the water comes out. And if we know the absorption capacity, that's how much water can go in the rock, how much water can go in the sand. We can calculate that. We can figure out how much water would be inside of our rock and sand. So we're going to look at the change in mass before and after cooking. That's the amount of water that's in the cylinder. You can calculate how much water then was in the aggregates, right? And then you use the batch check information to find the amount of binder. Simple water cement ratio calculation. You can use air content. You can use unit weight to do this. Super powerful. And there's an app that does everything for you. Just type the information in the app, hit go, and it does it. It's pretty sweet. So how can we test it? How can we make sure it's right? Well, we made mixtures in the lab where we carefully controlled the moisture contents. And then, so we should know water cement ratio extremely accurately. And then we'll measure the water cement ratio with the Phoenix, and we'll compare. And for this data set, there's 9 different coarse aggregates, 3 different fine aggregates, different specific gravities, different absorptions, different water cement ratios, different paste contents, and the data looks like this. X-axis is what we think the water cement ratio is. The y-axis is what we measured the water cement ratio to be. The dashed line in the middle would be perfect agreement. And we have plus or minus 0.02 shown on there. That's about the variation of the test method. Notice every dot has an error bar on it. And every single one of them, for the most part, every single one of them is within plus or minus 0.02. That's 228 tests up there. 228 tests. Okay, each data point may be like 30 tests or 20 tests, depending on how many we ran at that different water cement ratio. Remember, we did with different aggregates, all kinds of different stuff. This is just a summary. Now, one thing that you want to pay attention to is in the upper left-hand corner, there's something called COV. That means coefficient of variation. That's how variable is the test. And it's 3%. I don't know if you know how variable the compression test is, but it's 10%. This is 3 times more accurate than a compression test. 3 times more accurate, more repeatable than a compression test. And you do it in 15 minutes in fresh concrete. And here is the microwave oven test, right there. Look how variable it is. Okay, that's why we didn't use it in the past. But this is powerful. This is helpful. This can get us out of so many troubles. How can this help us? Well, we can use the batch ticket information, get our design water cement ratio. How can we use this in the field? Well, we can do this exact same thing. We can actually use the batch ticket information to get the design water cement ratio and then measure the water cement ratio with the Phoenix. And we did this stuff at batch plants for 4 different projects on paving and bridge decks and substructures. And we had stuff that looks like this, ran off a generator in the back of a truck. So you can do this in the field. We do this in the field. People are doing this in the field right now. And here's some of the field data we got. Batch water cement ratio on the x-axis, measured on the y. Same number, perfect agreement. And there's a few data points that are a little bit higher. We'll talk more about those. So this data looks promising. This is pretty cool. About 15% of the mixtures, about 1 out of 5 or so, had a little bit higher water cement ratio, and all the testing was done at the batch plant. And I'm so proud. This company came to us and said, Tyler, you're telling us the water's high, but we don't think it is. We think it's accurate. What's going on? And I said, let's figure this out. So we went out there. We used the Phoenix to actually do moisture corrections. I know we have probes typically in our rock and our sand to figure out what our actual moistures are. We said, well, what is it really? And then we said, we checked the trucks, make sure the trucks were clean, make sure there was nothing inside of them, all that stuff like that. So again, we used the Phoenix to measure this in 5 minutes. We also helped them make sure their trucks were good. And then look at this data. This is field data. The x-axis is the batch water cement ratio. The y-axis is the measured water cement ratio. What we did is we took a truck and we batched out a certain concrete mix that they were using. So you can see one of them maybe like 0.31. Then we came back and we added water, a known amount of water. When we added it to the truck and mixed it back up, so we increased the water cement ratio by exactly 0.04. We did it again and again and again. We took 8 trucks, turned it into 32 different mixtures. Now, what does this mean? This means you can make very repeatable and very accurate water to cement ratio when you want to, when you have the ability to measure, when it matters. If it doesn't matter, no big deal. But if it does, it can be done. And look at the coefficient variation. That's that COV number up there, 3%. Same number I had in the lab, very similar number to what I had in the lab. And 88% of the data was within 0.01 water cement ratio. This is powerful, powerful, okay? because the Phoenix can consistently measure our water cement ratio within 0.01 in 15 minutes in the field. And the Phoenix can measure the moisture content of an aggregate within 5 minutes. So I'm going to ask another question. Have you ever had concrete rejected for high slump? Does anyone want to raise their hand to say this? Man, you guys don't live very challenging lives, okay? When I worked for Zachary, we got a lot of our concrete rejected for high slump. In Oklahoma, this is in Oklahoma, on a bridge, we were pouring a pier. And the maximum slump specification was 7 inches. And the concrete was rejected. And as the truck was leaving, I said, whoa, 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 whoa. Could I sample some of that concrete, please? And they did. First truck came out, specified slump was 7 inches. Slump showed up 9, okay? And I measured it with the Phoenix, or started to measure it with the Phoenix. And then they brought out another truck. You know, I'm not part of the spec. I can't get in the middle of everything here. They call the batch plant, they call another truck, they dial another one in, and it came in at 8. Rejected. I said, whoa, give me some of that concrete. And let's everyone look on the far right. See that number 0.47, 0.42? Both of them met the specification. There was nothing wrong with either one of the concretes. They just happened to pick a number 7 inches. Because the water reducer that we were using, it was a little bit higher dose than it should have been. Slump was higher than it needed to be. And they should have dropped the water. They should have dropped the water reducer. They dropped the water. They went from a 0.47 to a 0.42. They were already within the spec, but the slump was still out. This is silly. This shouldn't happen. But it does, because we don't have a great way to measure water cement ratio. So the water reducer dosage was too high. And the water cement ratio was correct. The concrete was rejected because people were just measuring slump. Now, before I got here, I was in Minnesota. Some people in the room were in Minnesota with me. And they were talking about water cement ratio there, and they've been measuring water cement ratio for a long time in their ways, and they've been looking at the Phoenix for about 3 summers now. And where they've been just measuring mixed water and aggregate moistures to getting a water cement ratio, then they've actually been using the Phoenix, and typically they were about 0.02 to 0.03 higher than what they were doing. That means just some water's finding its way, into the mix, but everything is great. They're happy, they're excited, they were very, very, very pumped about that. And they're not the only ones using it. There's about 5 different states that are using the Phoenix. Okay, there's 4 different contractors and 1 ready mix producer. Why are contractors interested in this? Because they don't want concrete rejected for slump or strength either. Hurts their schedule, hurts what they're doing. They want to move ahead too and provide great concrete. So they're stepping ahead, and they're also the ones that hire me. So what I tell them, hey, this would benefit you, this would help you, this would help your job. Some of them are listening, some of them are stepping up. So you can find more information. Gilson has these. You can find more information at this website. There's 3 different published papers out there, and it's helpful. It's helpful. It's a helpful tool. We found it to be very, very helpful on some of these projects as we focus on sustainability, because we don't have to have as large an over-design in our mixtures, and we don't have to reject concrete for things like mishandling cylinders and slump. So the Concrete Phoenix is a field test that can be used to determine water cement ratio in about 15 minutes, about plus or minus 0.01 accuracy. And the Phoenix can also measure the moisture content of the aggregates within 5 minutes. And if we know our water cement ratio, then this is an important step providing the strength, the durability, what everyone wants and everyone needs for their concrete, so we can lower our safety factors, lower how much extra cement we put in, not reject concrete when we shouldn't have been. And I said this before, I'll say it again. What if we could measure the water cement ratio in fresh concrete? What if you could show that your concrete meets the specification as it leaves your plant? I think there's power. I think there's a lot of power. We could measure what matters. There'd be less emphasis on strength and slump specifications. Let's talk about a possible future. We don't know what the future holds. We never do, but a possible future. Why are we making important decisions on how strength samples are collected, stored, and tested? What if payments based on water cement ratio and air? Could be done at your plant, okay, or verified someplace else. Strength could be used as information only, and there are certain states already pushing this. Minnesota's pushing that. Iowa's pushing that as well. And Kenny Seward from Oklahoma DOT has gone on record to say this: if there's a satisfactory Phoenix measurement on site, then I'm not worried about a strength measurement. That's pretty cool when the DOT is starting to see what they've been doing for years might need to be adjusted, might need to be changed, all right? So we need to start moving in that direction. So this is the last bullet item here. Design mixtures to reduce embodied carbon. I told you it was the last step. I told you it was the last one that I was going to focus on. But I'm going to just say that. How do we do this? How do we make this happen? How do we truly design these mixtures to have lower amount of embodied carbon in them? Well, if you dig into the details of a concrete mixture, more than 90% of the CO2 in an EPD comes from the binder itself. So the amount and the type of binder in your mixture has a big impact on the embodied carbon. So what I'm talking about is that if we can, there's all kinds of tools out there that we can use, and if we can focus on the binders, that's extremely powerful. And I'm going to first focus on Portland limestone cements, and I'm not going to go in great detail because I bet you guys know about them. You guys know about PLCs? We only have one PLC hand out there. 2, 3, come on. I'm just going to sit here. You better know about it. It's important. It's important. We've made a decision to move ahead in a direction with a technology that I think is powerful when it's done right. In Oklahoma, I always love to tell a story. We've been doing PLCs for more than 10 years in Oklahoma. My entire lab, 35,000 square feet, is built entirely with PLCs. Okay? I use PLCs in my concrete testing every single day. But I'll tell you a story that they don't always tell people. For the first 3 years in Oklahoma, we only used PLCs to do cement stabilization. Why? Because it gave us chances to tweak and learn and play, all kinds of different things, all right? And we're learning, but we're going to get to a great place. I promise you. It's going to be really, really solid, really, really awesome place. We're already there in Oklahoma, and you guys can do it as well. PLCs are here to stay, and I think in the future you're just going to see more. I mean, they will be everywhere, and you'll see more and more limestone replacement. It's just happening. It's coming. Okay, let's talk about aggregate optimization. Who's heard of aggregate optimization? Anybody? Surely it's the same type of people that own the PLC hands, right? It's been around a long time. This is not new stuff. And I know there's always some doubters out there. I was a doubter at first, right? And I asked this question, do aggregates really matter in a concrete mixture? So I did an experiment. I made 5 different concrete mixtures. And on a piece of paper, every one of those 5 mixtures looked exactly the same. On a batch ticket, they looked the same. Certain amount, 1,850 pounds of coarse, 1,250 pounds of sand, 445 pounds of cement, 180 pounds of fly ash, 250 pounds of water. But every single mixture had a different gradation. That means a particle size distribution. That means this stuff that you get from your suppliers, quarries, the gradations were different. The S-shaped curves were different. And the mixtures performed totally different. Batch ticket looks exactly the same for all 5 of these. Upper left-hand corner, deficient amount of fine sand, it kind of just disintegrates and falls apart. Upper right-hand corner, too much fine sand. It's stiff, too much surface area. Lower left-hand corner, high amounts of intermediate. Okay, it's kind of stiff. Lower right-hand corner, high amounts of coarse aggregate. Oh my God, it's segregating, it's coming apart. Okay, and the one in the middle, that's just right. Okay, that's the mix that got it just right in the middle. It's not just about slump. We can also look at these mixtures and how to finish them. Now, what's going to happen if they get the mix on the upper right? They're going to add water, aren't they? I did. When I worked for Zachary, I did. I know, I'll say it publicly. Because I'm there, I got to build something, I got to construct it, I can't finish it, I can't make it smooth, I got to do what I can. I get it. I understand where they're coming from. That's not good. Upper right-hand corner. Upper left-hand corner, that's not good. Deficient amount of fine sand. How do you fix that? They add more paste. They add more cement. They add more whatever else to the mix. Okay? Lower left, excessive intermediate aggregate. It's kind of segregating coming out. Lower right-hand side, excessive coarse aggregate, again, is kind of coming out of the mix. And right in the middle, it's just right. Now, I'm not here to tell you what to do. You know your concrete way better than I do. You know your materials way better than I do. And I'm not here to tell you what to do. Okay? But what I am here to tell you is gradation matters. And I think on some level we all know that. Okay? Gradation matters. And a tool that's simple, a tool that's easy, A tool that was developed with $1.5 million of research was this one, the tarantula curve, okay? It was developed out of my lab. On the x-axis is the sieve number. On the y-axis is the percent retained. And it's a total aggregate distribution that goes inside those curves. And one thing that's cool is every time you go outside one of those limits, we have told you specifically what's going to go wrong, because we've done it in the lab and the field again and again and again. And this is an essential tool that I use to design all of these concrete mixtures. And it's not just about the curve at the bottom. There's a coarse sand check and something called a fine sand check. That's really important as well. We have coarse aggregate, we have intermediate aggregate. We have to make sure that they're in check. We have to make sure that these things are in check as well. Okay, so those are big, important things. And you might say, well, why does it look like a tarantula? Well, I think the things on the bottom look like legs, and I think the things at the top look like the body and the head. And I developed the dang things. I can call it whatever I want, right? So as far as I'm concerned, it's called the tarantula curve, right? But if you want to find out more, there's websites. It's free. I've got videos on how to use it. I've got spreadsheets on how to do it. They're all free, okay? Type in that tell you how to do it, step you through the process, step by step by step. If you want to do it, I want to help you do it. You might say, okay, I'm still not convinced. Oh, I know you wouldn't. I get it. So let's talk about LaGuardia Airport. This is a great story. I was asked to come speak at the ACI CIB group in New York City. It is a very, very cool group, extremely cool group, really hardcore, awesome concrete people I'm sure like you guys out there. And Kaz Bernanke, I love Kaz. Okay, he called me on the phone and he says, Tyler, we want you to come in. We want you to talk about your bug curve. It's like, okay. He says, and we don't believe in it. And I said, well, Kaz, why are you having me come if you don't believe in it? He said, we don't believe in it. And I said, well, what if I could help you learn more about it? I go, why don't we do some trial batches? Let's do some trial batches. You pick a mix, whatever. I'll run it through the tarantula curve. I'll suggest an alternate mix. We'll see how it goes. So what Kaz does, I love Kaz, by the way. Good friend of mine, okay? Back then, we weren't as good of friends because we didn't go through this experience together, okay? He gives me a mix that the contractor had done like 30 trial batches on. The contractor had been dialing it in and what they thought was the creme de la creme mix, like the best mix, like the best bridge deck mix they'd ever seen and done in their entire life. Kaz didn't tell me any of that. He just sends me the mix and I get it and he says, I need it in a day, you know? I'm like, great, Kaz. So I type it in and I look at it, and that's the original mix on the left, and that's the mix I came up with on the right. And these numbers don't mean much unless you look at the gradations and unless you look at the tarantula curve itself. And we'll do that, okay? But you notice I was able to pull out 50 pounds of binder. And he literally said, that's impossible. And I said, well, let's trial batch it, baby. Why are you doubting me, man? Come on, let's try this. Okay, but what I saw is what the mix he gave me, if I plotted in the tarantula curve, it was too high on the number 4. And I knew that if they were happy with that mix, that I could drop the number 4 down, and I could raise up other places, and that I could take out paste. If they were happy with that mix, I could take out paste and still make it perform about the same. So I did that. If I could go back, I would in the slides, but you can see before and after, okay? But that's the after. Notice the before, it was poked up a little bit, all right? Oh, look at that. Thank you, my friend. There's the before, right? A little high. Here's the after. Tweaked. That's all I did. Pulled out 50 pounds of binder, okay? Added a little bit more water reducer, okay? And I said, okay, let's trial batch it. And I like to do my trial batches with no water reducer at first, no admixture. I want to see how much water slump, and I want a certain amount of water slump. And they said they did that. They got a 0-inch slump right there, so it wasn't looking good so far, okay? But I said, okay, great. They added in the same amount of water reducer and the air that they used to use in the past, okay? And that's what they were getting. And then we added a little bit more, right? And that's what they got on the right, okay? And this is a poly. It performed really, really well. That they said that looked great. They went to finish it. They thought it finished great. And so they used it. And one thing they said, the contractor used it the whole next season. They said it was amazing. They said it was better. They said it performed better than the mix with a higher cement content, and it was less expensive. They were excited. They thought it was awesome. And so the new mixture has good workability and with just a little bit more water reducer in it. Okay, so in summary here, how do I get mixtures inside the tarantula curve? How do I do that? Well, it doesn't have to be that you need 3 different aggregates. It doesn't have to be. Sometimes you can do it with 2, but oftentimes in process you need 3 because you need levers. When one lever is out, you need to pull the other 2 levers to get yourself back in, all right? Typically. Some people say you need 4 or 5. I don't think so. I think 3 is plenty, and 3 works out as well. Again, if you're out on 1, then you use the other 2 to pull yourself back in. What am I talking about? If I have a mix that's out on the 20% limit, notice I can decrease the 57 stone or the larger aggregate. I can increase the intermediate, and sometimes as much as 200 pounds is all I have to change. 200 pounds. And I go from a mix that's poor, people are cussing and fighting, to a mix that everyone's super pumped about, super excited about. 200 pounds. That's it. But it's got to be the right 200 pounds. And the tarantula curve just helps you with that. So does your mixture have to be within the tarantula? No. It does not. But you'll need more paste if you're out, okay? Because that paste helps you overcome the challenges, the conflicts that happen as stuff starts to flow. This usually means greater cost, usually means greater risk for cracking, all right? And here's a guy I worked with on the Major League Soccer stadium in St. Louis, Dan. He said, to date, every mix designed with the tarantula curve has outperformed expectations in standard mixtures. The process has helped us been extremely efficient. Mix concerning cementitious requirements, admixture usage with outstanding finishability. And then he said, P.S., first time I saw the tarantula curve, I thought, yeah, right. But after using it with several critical mix designs, let's just say I'm using it from here on everything I can. Thanks. It's pretty cool. Pretty cool when people say that things have those type of experiences with it. So it's about the last one here. The last lever that we can pull. Low SCMs, you get about 20% reduction. High SCM content, that's when you get about 45% reduction. And that 45% reduction is where people were going to be moving. Get ready. Get ready. It doesn't mean next year. Doesn't mean the year after. But get ready. That's where people are moving. Okay? Higher SCM production. Higher SCM usage. And we're going to have to figure that out. And you know what SCMs are. They're fly ash, they're slag, silica fume, ground glass, natural pozzolans. All useful tools. But I know what you're thinking, because I'd be thinking the same thing. Are we going to have fly ash in the future? Does anyone wonder that? Are we even going to have fly ash? Well, did you know that for decades and decades and decades, the U.S. has only used about 40% of the fly ash that's been produced every year for decades? So what happens to that other fly ash? It's winding up in ponds. I've tested more than 40 different ponds from around the United States. Future is bright. We've got some really good fly ash in the ground, okay? It's going to cost to get it out, clean it up. I don't know where that fits into your market, okay? But did you know there's 2.5 billion tons of usable fly ash in the ground right now? 2.5 billion. That's enough fly ash at our current levels for 170 years at our current usage levels. We're going to have a lot of ash. And ASTM's in the process making changes to make these things usable and practical. And thank goodness for people that are out there doing that. Eco Materials is already advertising. They're doing this in Georgia. 600,000 tons per year. That's what they said is going to be coming out. Okay? Here's a map publicly available. Those are known fly ash locations all around the United States. Now look in California. Do you believe there's none in California? Do you believe there's none in California? It's like drilling for oil, right? You find new stuff all the time. They aren't permitted, they don't necessarily know where they're at, but there are plenty of pits that are out there that are going to be make fly ash available. So in summary, I believe that sustainability is another way for you, for the concrete industry, to give your customers what you want. And people are stepping up to these challenges, and they're doing it with innovation and they're being rewarded as they do it. And how can you help these organizations? I've given you the 4 bullet items. I could talk for an hour on each bullet item, but thank you for having me for this hour today to talk about a little bit for every single one of them. Okay? And the most important thing I could tell you is this. We're not going to do anything but what we've done in the past. I told you this before. This is not rocket science. This is just how we treat humans with respect. This is how we just move together as a team to make this happen. And that's what's going to be the secret. Communication, collaboration, being honest, paying for trial placements, learning and getting better in innovation. I'll tell you what, I've got this YouTube channel. I hope you got some value out of what I talked about today. I make this because I think education is our number 1 challenge in our industry, all right? And I hope you'll use it to help yourself. And if you would do me a favor, I want to end this lecture by everyone together saying, I love concrete on the count of 3. And I do this in my concrete classes every day, every single day at the end of class. I said, we're going to end class today as we end every single one. 1, 2, 3, and they all yell, I love, can we do that? The reason I do it is because I want to drive the love of concrete into their soul, all right? And I know you guys already have it in your soul because I'm expecting a really loud one. Are you ready? Ready? So I'm going to say 1, 2, 3, and we're all going to yell, I love concrete, okay? 1, 2, 3, I love concrete. Yes! Thank you so much. Really appreciate it. It's been such an honor to be here with you.
Thank you.
Thank you so much.
Fantastic. Fantastic. Do you want to take a question?
If they got a question or two, I'm happy to take. We got the clock down there says 3 minutes. So.
Yeah, we've got a little bit of a time issue, but if anybody has a question,
Terry.
besides Terry.
Tyler, for the presentation. So one thing that you said that I'd like to, slump testing is irrelevant for the most part, right? So how do we get specifiers to stop specifying slump
Yes, sir.
or accept and reject? I'd be curious how we get
Great
there.
question. So he asked, how do we get specifiers to stop specifying? And I totally agree with you, Terry. And when I talk to specifiers about that, and they say, well, the reason I specify slump, and I'm not lying to you, my friend. They say the reason I specify slump is because I want to control water to cement ratio. And I tell them back, I said, well, that was great, that was amazing in 1918 when TC Powers came up with the slump test. In life, I'm not knocking that, okay? I'm just saying that's just the truth, brother. That's when it came out. But 1918, that was amazing. And back then, in the past, that was the way we could do it. But the slump test is about consistency. And people need to stop using the slump test to specify concrete. But I'll tell you, Terry, I think that if you could give them an alternative that actually measured what they cared about, I think we could get away from some of that. That's just my belief. Any other questions? That's a great one. Knocked him dead. Awesome. Thank you, everybody.
You going to stick around for a little bit? Come to lunch or whatever?
I'll be around as long as I can.
Okay, great. Love to have you. Hey, Terry, you could learn a little bit from him, I think. I don't know. Terry taught me everything I know about concrete when I was at Grace. He spent like an afternoon with me, and he said it was hopeless. Thank you very much, Tyler. Very much appreciated. You've given us a lot to think about as we continue advancing concrete's role in the sustainable built environment. So that concludes our general session. For those participating in the NRMCA Promotion Committee meeting, it begins at 12:30 in the Debussy 1 to 2 rooms, followed by an NRMCA, NSSGA, PCA Joint Government Affairs session in the Beethoven room at 3:15, and a joint chairman's reception at 5:30 in the Brahms 1 to 4 rooms. So that's the agenda for the rest of the afternoon. Last but not least on our agenda for today is a reminder to join us at the Concrete Pack Rat Pack Dinner and auction in the Encore Ballroom later this evening. Promotion is in Encore 1 through 3. That would have been great because I mispronounced Debussy. But anyway, enjoy the rest of the day. Thanks a lot for your attendance.